Hey everyone, we're looking at the net force worksheet number 5 here. You've got a 70 kilogram skydiver jumping out of the plane. First thing they want to know is what is the acceleration of the diver the instant they leave the plane. So what I'm going to do here is kind of walk you through this example. In my system schema, I've got a person, and that person is interacting with the Earth. The Earth is attracting them with a force. That force is going to be our force of gravity. As long as I eliminate the air resistance, then I don't have to worry really about anything else. The instant you jump out of that plane, the only force on you is a downward force of gravity. So if that's the case, what I want to do is see that my forces are unbalanced and know that I'm going to be constantly accelerating towards the ground. The problem gives me that he's 70 kilograms of mass, so automatically I can calculate the force of gravity by doing mass times 10 newtons for every kilogram, which means gravity's pulling him down with around 700 newtons of force. So using Newton's second law, the net force is going to make my mass accelerate, F equals ma. I know the net force is the only force there, which is 700, so I'm going to put that in for my force. My mass is 70 kilograms, which means that the instant I jump out of that plane, the acceleration has to be our free fall acceleration of negative 10 meters per second squared. So you might have known that right off the bat without having to do any of this work, but you can prove it here with Newton's second law. Now all that's changing in the second one is that we're adding in some air resistance. We're adding some friction in as you start to fall, which means there's another force now, and that force is an upward resistive force of friction. They say that the upward force here grows to about 300 newtons. Again, using Newton's second law, F equals ma, and remember this is a net force. We have to look at the combination of those two forces. Since they're in line with each other, they're going to cancel in this case. You're going to have the friction upwards, subtracted by the gravity downwards, equals mass times acceleration. I've got 300 newtons of friction, minus my 700 newtons of what gravity's doing to me. Put in my mass again, which leaves only a total force on my body of about 400 newtons. And it's minus because it's heading downwards. So now it looks just like our last problem, except I don't have the full amount of 700 newtons on me. What I have now is an acceleration of 5.71 meters per second squared. So I'm still accelerating, I'm still unbalanced, I'm still picking up speed, but just not at the rate that I used to in the first problem. So good luck on these.